Alright, so recall from last video, we talked about the greatest common factor and finding the greatest common factor. So the greatest common factor is the largest term that goes into a list of given terms. So for example, if I have 4x and 8x, I want to look at the numbers first. My greatest common factor between 4 and 8 is 4. My greatest common factor between x and x is x. So 4x would be my greatest common factor between those. So this section, I'm going to be actually factoring out the greatest common factor. So when we do this, not only do we find the GCF, but we take it out of the expression. Looking at our first example here, I want to find the GCF of 12x and 16y. And I'm going to take that out of the expression. So my greatest common factor of 12 and 16, remember we can list them out, so I'll do that for this problem, but I'm not going to do that for all of them. So my factors of 12 are 1, 2, 3, 4, 6, and 12. My factors of 16 are 1, 2, 4, and 8, and 16. So my GCF of these expressions would be 4. Neither of them have a variable in common, so I'm just going to kind of ignore that. So when I'm factoring out my GCF, I want to divide each expression by 4. So that 4 is going to come on the outside of the parentheses. Well, what's 12x divided by 4? That's just going to be 3x. 16x divided by 4 is just going to be 4y. So when I factor that out, my expression is going to look like this. 4 times 3x minus 4y. You can always check your work by going the opposite way and distributing, right? So if I checked my work by distributing, I get 12x minus 16y, which is the same as our original expression. So if you're ever not sure if you're getting the right GCF, if you're factoring it out right, you can always check your work. Let's look at number 2. This one I'm going to have a GCF for my variables and my numbers. So I know the GCF of 4 and 6 is going to be 2. Well, let's look at our variables now. One is x squared, one is x. Remember from last lesson, I want to look kind of for the lesser of the two. So I'm going to divide them each by x, because that's the lesser exponent of the two. The first expression doesn't have a y in it, so that cannot be included in my GCF. Let's try this. We're going to divide each of these expressions by 2x. So I'm going to pull that out. Well, what's 4 divided by 2? That's just 2. X squared divided by x, remember our exponent rules. X is the same as x to the first power. So if I subtract my exponents, because I'm dividing, what's 2 minus 1? That's just 1, so we just have x there. For my next expression, 6 divided by 2 is 3. X divided by x just cancels itself out, and then y just stays there. So my final expression would be 2x on the outside of the parentheses, and then 2x minus 3y on the inside. Remember, I can always check my work by distributing. So I get 4x squared minus 6xy, and I'm back to my original expression. So your answer is going to be the factored form where I take out that greatest common factor. However, you can always check your work by distributing. And I would suggest that especially early on as you start practicing. Let's look at number 3. I'm going to factor out a GCF from all of these. Well, not all of them have variables, so I know I cannot take a variable out. However, I can look at my numbers. So I have a 6, a 15, and a 9. So what is my GCF of 6, 15, and 9? Take a second to think about that. All right, well, hopefully you got 3. So I'm going to divide each of these by 3. So 3 comes on the outside, and I'm left with 2x squared, because 6 divided by 3 is 2, plus 5x plus 3. And like I said, you can always check your work by distributing, so let's practice that just to make sure this works out. I get 6x squared plus 15x plus 9, and I'm back to my original expression. All right, let's try another one. So looking at number 4, we're going to have to look at the variables and the numbers. So let's always look at our numbers first. What's in common with 10, 20, and 15? What's my GCF of that? Well, hopefully you notice they end in either a 0 or 5, so I can take a 5 out of each of them. Looking at our variables, a is the only one that's in common with all three. All three of them have an a here. So right here, and right here. And remember, I want the lesser of all of the a's. So I'm going to go ahead and take out just one a from each, and we'll see how that works. So I'm going to factor out that 5a. That's going to be on the outside of the parentheses. So looking back, whatever I'm dividing everything by comes on the outside of the parentheses. Whatever's left stays inside the parentheses. Let's go ahead and divide. 10 divided by 5 is 2. A divided by a just cancels each other out, and we're just left with that b there. Minus 20 divided by 5 is 4. Again, the a's cancel out, and I'm just left with c there. And lastly, 15 divided by 5 is 3. A squared divided by a, remember that a has an exponent of 1, so I'm just left with 1a there. So here's my final expression. All right, let's try just one more, and then I'll have you try the last one on your own. All right, looking at this one, I have 6a squared b plus 4ab squared minus 2a. Always start with those numbers. So the greatest common factor is going to be 2 for each of these. They don't all have a b, so I know I cannot take a b out of all of them. However, they do all have an a, at least one, so I'm going to factor out also an a. And again, whatever you do to one, you have to do to the other. So what I'm dividing by is going to come outside of the parentheses. What's left stays inside. So 6 divided by 2 is 3. A squared divided by a is just a. And then that b is also still there. Plus 4 divided by 2 is 2. The a's cancel out here, and that's left with b squared. And then the last one, 2a divided by 2a, those are exactly the same. So you're not left with 0. When you have the same numbers and you divide, you're going to be left with 1 here. So be careful. Common mistake is a lot of people think, oh, these both cancel out, so there's nothing left there. No, that's not right. If I distribute, I need something there in order to distribute. So this has to become a 1. Think about it like this. What's 3 divided by 3? Those are the same numbers. So when I divide them, I get 1. Right? So my final expression would be 2a on the outside, and then 3ab plus 2b squared minus 1 on the inside. And again, I can always check my work by distributing and see if it comes back to our original. All right, go ahead and try number 6 on your own, and then you can check your work once you finish. Go ahead and pause that video right now. All right, so hopefully you saw that our greatest common factor for the numbers is 7. For the x terms, it's going to be x squared, because that's the lesser of all the exponents. And then for the y terms, they all do have a y, but only one y is shared from all of them. So I'm going to divide everything by 7x squared y. That stays on the outside of the parentheses. And what's left inside is 3xy minus 2 minus 4y. Now I'll show you how you got all those. So hopefully the numbers make sense. 21 divided by 7 is just 3. X cubed over x squared becomes x to the first power, just x. Then y squared over y to the first just becomes y. The second term, actually all of my variables cancel out, so I'm just left with 2. And then for the last term, my x squareds cancel out, and then when I simplify the y's, it just becomes the 1y. So here is my final expression. All right, so hopefully that helps you with factoring out those GCFs. I think, again, you just need to keep practicing this in order to really become an expert at it. So make sure you're moving on to your choice activity and getting that practice you need. Until next time.